Would you like it if I said that again real quick? Since I'm recording now? Okay. So just remember, when it comes to particle motion, be ready to take the derivative to get velocity, the derivative again to get acceleration. Make sure you stick within the domain that is given, that time frame when you answer all questions. Speed is always the absolute value of velocity. So if you're asked for speed at a particular time, make sure you get a positive answer for that. You're moving in a positive direction when velocity is positive, negative direction when velocity is negative. To do that, you have to solve for what makes velocity equal to 0. And then again, make sure you stay within the domain. So what I'll do is I'll make number lines for velocity where I put the beginning and end of the domain, and anytime velocity is 0, and then check with time values. Anytime between 0 and 3, plug it into velocity, see if you get positive or negative. And that tells me that I'm, for 3 seconds, moving to the right, for the next 2 seconds moving left, and then the next 2 seconds moving to the right. And when it comes to slowing down, speeding up, you have to bring that velocity information that we were just talking about, that whole bit of information. And you can see that number line showing up right here. I'm trying to make it show, yep, right there. And I've got the velocity being 0 at 3 and 5 written on that timeline, but I add into it anywhere the acceleration is equal to 0. Then velocity is positive, negative, and positive. Acceleration, negative before 4, positive after 4. So then speeding up and slowing down is about whether the two of them are the same sign or opposite sign. And always be careful, read the directions carefully. Sometimes problems will say, when is velocity increasing? And then it is just acceleration being positive. But if it's asking when the speed is increasing, it's when both acceleration and velocity are the same sign. Then total distance traveled, go back to velocity and look at when was velocity 0, because you've got to find how far did I move when I moved in the positive direction? How far did I travel when I moved in the negative direction? So this one is giving just a time interval from 0 to 4. So you've got the beginning of that time interval, the end of that time interval, and any time that velocity is 0 between those times. And if you find your position at those times, so I showed, like, we've got the position function, then from there, you're doing from time 0 to 3, how far did you travel? So just take the difference of those two positions, make sure you take the positive value of it, and then you're going to add to that how far you traveled in the second time interval from 3 to 4, which ended up being 2 units, but make sure you absolute value it and then add them together. When we hit integration, we will find out. So you could have just taken each. Actually, don't. It doesn't look good if you're finding the position at each integer value. It shows that you don't know what you need to do. Also, velocity isn't necessarily going to equal 0 at an integer. If it was 0 at, I don't know, 35 fourths, then you would have to plug 35 fourths into this position function, into the time of the position function. So you don't want to look at it for every single time, only the times when velocity is 0 and the beginning and end of the time interval. Don't add in more times. The AP test will not like that if they see that's what you're doing. then we will get a better, nicer way with integration to find total distance traveled, but from now it's kind of painful. And now I'll admit something to you. You realize the arithmetic errors that are possible in total distance traveled. It's my personal nightmare to grade. So take from that what you think you would take from that. I don't want to create my own nightmares of grading. The last time I put that on a test, I got so frustrated with all the arithmetic mistakes that I swore to myself I'd never go through that pain again. I found that you guys know what to do. It's a matter of doing arithmetic correctly. Dear. Then with related rates, you've gotten a lot of related rates problems. I think earlier someone said those light posts, so shadow problems. Anything can show up. I can't give you a ton of related rates problems in that time frame. So it's kind of like throw a bunch of problems in a bag and grab one or two of them and go, which one am I giving them today? So as far as taking a look at these, maybe we can go over this one. So that might be better if I I'll talk through it. So, Nope, not there. There. Okay. So if you wind up with the ladder problem, we've got our right angle and a particular length of a hypotenuse, 12 feet long. Honestly, the biggest thing with related rates is read the problem a few times before you start out. Read carefully. The bottom of the ladder slides away from the wall. Now, realize when they say that, they're actually talking about just this point alone moving. But what we end up doing is we take a distance between that moving point that we know the rate of change for and a point that is not moving. And if I look at that distance between an anchored point and the one we know how quickly it's moving, that matches the rate of change of this length. And because it's sliding away from the wall, it's gaining. So that gives me a dx dt, positive. And the main thing with the shadow problems are understanding the difference between how fast a tip of a shadow moves versus the shadow length. And I'll talk about that in just a minute. So then in part A, you're wanting to find the rate of change of the angle between the wall and the ladder. If you have a right triangle and you're dealing with an angle rate of change, know that your go-to is SOHCAHTOA. You're looking at what two sides do you want to bring into the mix. And if you have a constant side, you want that constant side. Make your life easier. You've got to include the side that you know the rate of change for. But if you bring the constant side in as well, that's going to save you grief. So then if I write x divided by 12, that's going to be opposite over hypotenuse. And then you know that that means sine theta. So just kind of take a moment to take a look at that and see that if you just kind of relax your mind, have confidence that you can get the right equation going, you can do this. I think half the battle is believing that you can. In fact, it might be more than half the battle. So then once you have that equation, then carefully take the derivative with respect to time, because this step is the entire reason for the word problem. So with respect to t, both theta and x have to be implicitly differentiated. Derivative of sine of blah is cosine of blah, and just keep thinking chain rule. Give mommy her baby, multiply by derivative of baby. Then on the other side, you can save yourself some grief if you take 1 over 12 as a constant multiple to the x, and then go, what's the derivative of x with respect to time, dx dt. And then at that point, make sure, one thing you can do, because I've seen tests where if a person stopped to do this, they would realize that they need to fix something. And that is, look at the variables. Come on, do what I'm asking you to do. Oh, I see, lag time. Look at the variables. Make sure you have a rate of change for each variable. If you don't, you messed up a chain rule. Come on, lag time. There we go. Too many people on the internet. Just take that time to make sure that you have rates of change for each of the variables involved, and you could save yourself some grief. Then it's plug in the information given as well as the when information. So given was dx dt is 3. And then the other thing you need to find is cosine theta. Don't find theta, find cosine theta. The when is when the foot of the ladder is 8 feet from the wall. And realize that you can find the third side through Pythagorean theorem. So 12 squared minus 8 squared square rooted. And you have access to calculators too. You can write this as a square root or as a decimal. I don't care which you do. It's up to you. You'll end up getting square root 80, and I'm just going to leave it in square root form. And then cosine will be the adjacent side over hypotenuse. Again, don't go finding theta with these problems. So root 80 divided by 12. And from there, it's a matter of just doing some arithmetic correctly. That's where everything goes downhill, right? No, actually, you know what? You guys get to test second period. You're lucky there. Second period is a time when you've had some time to wake up, but you're not tired from having done most of your day already. You might be getting snacky hungry, so bring snacks. Oh, wait, you're at home. You don't need to bring snacks. Prearrange snacks next to you so you don't have to get up. So that was part A. Part B, how fast is the ladder sliding down the wall at the same moment? Now I want to go back to, you were given this bit of information. While we just found d theta dt, we could use it because we did find it. You don't have to. But do realize that you need to go back and take away your when information. That when information is no longer there until you have taken a derivative. So you've got x, you've got y, they want you to find dy dt. that means you need to make sure that you have a relationship between x and y. You've got a right triangle. Pythagorean theorem is one of the most common formulas you'll use for related rates. That means you have x squared plus y squared equals 12 squared. And be careful when you're taking the derivative. You may want to really quickly go 12 squared. Your derivative is 0. You won't fool me this test. Because I can't tell you how many times people write 2 times 12. So just be cautious. Then, derivative with respect to time. Even though x, you're used to just going 2x, it's with respect to time, not x. So, 2 blah times the derivative of blah plus 2 blah times the derivative of blah. And I'm going to divide both sides of the equation by 2. And now the when information comes back. When x is equal to 8, and you already know that at that time y is root 80, and you can just start plugging that right on in. So 8 times dx dt, which is 3, plus y times what you're trying to find. And a little bit of addition, division later, you've got the final answer. So that was that related rates problem. The other related rates problem was the water tank. Paste. Okay. Let me make you aware of something. On the Go Formative test, if there are pictures, I will put pictures in the Go Formative test. For the sake of your printer ink, I'm not going to put the picture on the PDF version. I'll try to keep that tidier for printing purposes. So just be aware of that. Because if I put in a picture where it uses a lot of ink, it's just unnecessary. Okay, moving on. Anyway, inverted circular cone. And you are told that the base radius is 4 meters. The height is 6 meters. So when you look at the rising water level or maybe shrinking water level based on the problem, it's going to have a 2-to-3 ratio between its radius and height. When you hit any related rates problem, though, your first focus should be what are rates of change they're giving me? What are rates of change they're asking me for? You can draw the picture first, but as far as now I've got to find it. There it is. Okay. After your picture is drawn and everything, your first focus is what rates of change are we working with here? So 2 cubic meters per minute, write it down. And it's being pumped in, so positive 2 cubic meters per minute. and there are no other rates given, read it a few times, underline, highlight. One of these tests coming up, you're going to have those Google Chromebooks that the school is going to pass out at some point. And then you can nicely highlight and underline and everything. Anyway, what are they asking you to find with rate of change? Find the rate at which the water level is rising. They're asking you to find dH/dt. And again, no other rates are given, and you may need to read it a few times to catch all of that. Now, the next thing that I do once I've kind of analyzed who are my rates, I need an equation that uses those two variables. And I don't know any other rates of change. I don't want other variables around. So when I look at this formula, which you would be given on a test, I realize, yes, I have V, I have H, but I also have an R, and I do not know its rate of change. There's a long way, but let's look at the short way. The short way is to realize the relationship that radius has with the variables before you go into derivative taking. That will save you so much time. So what relationship does R have with H or with volume? And then it's this ratio. So R is to H as 2 is to 3. And then I can substitute. So I'm going to write pi over 3 instead of 1/3 pi, R squared H, and that means 2/3 H. Simplify that a little bit. So let me see, that's going to give me a 4 pi over 27 h to the third power when I do all that multiplication. So now, ready to go. Make yourself aware there are two variables. You better have two rates of change. So now it's time to go in. dv dt, constant multiple, and then blah cubed derivative is 3 blah squared times the derivative of that baby with respect to time. Double check both of those variables. Do you have rates of change for both of them? Yes. Then it's plug and chug time. And I know that dv dt is 2. And I need to find dH/dt. So the only thing left over is some when information for the H. And it was when the water is 3 meters deep. Now, it's possible that you could be given, instead of given the height, you're given the radius. How do you find height if they tell you radius? And then hopefully you see, yeah, those proportions right there. So know that sometimes the when information isn't the exact information you need, but it's enough to find the information you need. And you probably have already dealt with whatever formula you need to be looking for in this problem. Keep that in mind. But then at that point, it's just multiply, divide, and you've got your answer. Okay, did anyone want me to go over problems from yesterday's quiz? Because that would be one thing that I don't have up in a video. Okay, let me find that. And then go there, and then click there, and then click there, and then click there. And I'm going to grab number 2. Oh, yeah, and that helps us with those shadows. Just know that a lot of the issues with shadow problems are read it a few times before you decide what it says. Okay, so we have a person 2 meters tall walking directly away from a street light that is 8 meters above the ground. So what we have is something that is 8 meters vertically tall and someone who is 2 meters tall and ground. That makes a right angle. The person is, I need to make sure I can see it if you ask a question. There we go. Yes, the test is on GoFormative tomorrow, but I will also give you a PDF version that you can print out, but you need to upload your pictures. So the person is walking away from the street light. Now, if you want to look at the speed of that person walking, that's the speed of this point in particular moving. If you take that one point to an anchored point that is not moving and look at the distance between those two, I'll make that an x, then that dx dt is the same thing as how quickly the person is moving that one single point. And because they're walking away from the street light, this is going to be positive, whatever the speed is of that walker. Now, with the shadow, this does say we want to, if the person's walking at a constant rate and the person's shadow is lengthening at a rate. They said the shadow is lengthening. The shadow is made up of where that person stands until you reach the tip of the shadow. That picture is not proportionally correct. Look, you grew. Okay. I'm going to erase this because that gets confusing. So the shadow is from where the human stands to the tip of that triangle. It is asking about that shadow lengthening or telling you about it. So I'm going to put an S for shadow, and that is this distance. It includes 2 moving points. So know that it is not the rate of change of the person walking. It is not the rate of change of the tip of the shadow. It is the rate of change of the length of the shadow. And it said it was lengthening, so positive 4/9. Now, what they want us to find is the speed of the person walking, so we're finding the dx dt. And, read it a few times, get straight whether you're dealing with length of shadow or tip of the shadow. Are you starting to see the difference between the two? So then take a moment to look at what are my rates of change? Who are the variables involved? I need those variables involved in an equation. And the shadow problems are looking at ratios of 2 similar triangles. So 2 meters is to 8 meters as S length of shadow is to this entire length, S plus X. And you might set the problem up a little bit differently. When I cross multiply, I'm going to get 2 times S plus, oh wait, silly me. How about I reduce the fraction? Yes. Now that when I cross multiply, I have S plus X is equal to 4 times S. I can combine my S's together so that my derivative isn't as much to do. And now you have an equation that relates the variables that you're needing to deal with rate of change. Take a moment to say, I've got two variables, I better get two rates of change out. So with respect to time, dx dt, and with respect to time, ds dt. Now, the shadow is lengthening at 4/9. Then the speed of the walker is going to be 3 times 4/9, which will then be 4/3 is their speed. Okay. Do you want to see any of the other quiz problems from yesterday? I'm looking in chat. Let me point out to you some things. Let me point out some things that people tend to get messed up on. So I'm going to write a function down. You're going to take the derivative. Yeah, we can do number one on that quiz. So how about you try taking that derivative, and I will find question number one on the quiz while you differentiate. Let me go ahead and start with the differentiating since we are limited in time. People mess up the 3 to, or the derivative of b to the x terribly, absolutely terribly. Don't use the power rule. Power rule is when the base is the variable and the exponent is a known number. So the exponent rule says the derivative of 3 to the blah is 3 to the blah times what? Times what? Oh, before that though, the formula for, what is the formula for b to the x? Right. You've got to know these formulas. You have to study them. You need to know this is natural log of the base times b to the x, not natural log x times b to the x. And natural log b is multiplying to that b to the x. Then to keep going, that was derivative of 3 to the power. Chain rule says give mommy her baby and then multiply by the derivative of that baby. And then you can step back, refocus, say, who am I now taking the derivative of? Just one formula at a time. If my lag time will... It's reminding me of dial-up days. Ask your parents about dial-up days. Okay, anyway. So I am now focused on a new function that I need to take the derivative of. You may need to write it to the side to kind of look at it, think about it, and then realize that you've got a function inside of inverse sine. You're going to have to chain rule, but you're first going to think, what is the formula for inverse sine? Just what is that formula? And then you go, I remember it's 1 over the square root of 1 minus blah squared. And then you go back to, I'm chain ruling. So I am going to give mommy the baby and multiply either to the side or up in the numerator, it's up to you, by the derivative of root x, giving you 1/2 x to the negative 1/2. You don't have to simplify your answers. In fact, it's easier for me to grade if you don't. If you don't simplify, I can see your derivative process as I look over it and see that you understand what you're supposed to understand. Now, be careful that you do not mix up this formula with the natural log formula, because that's what happens. So I'm just going to throw out at you, if you have log base b of x, what is the derivative formula? So make sure you've got that memorized. In the denominator, you have just the variable multiplied by the natural log of b, not the natural log of x, the natural log of b. So if I gave you, for example, log base 2 of inverse tangent of 3x, I'll do this and then I will go to that quiz problem. Could you take the derivative of that? And looking at the time, I feel like I should just get going. So you start off with realizing, come on, lag time, you're killing me, lag time. I find it helpful to circle the baby function and then see that this is log base 2 of blah. Derivative formula. 1 over the natural log of that base times, now normally it's just x, but it's chain rule. So where x normally goes, I've got to put in this function that is the baby function. So plugging in baby times derivative of baby, you can either multiply on the numerator or to the side. But then you've got to turn to, all right, now I'm taking the derivative of inverse tangent of 3x. And I'm going to write it down. I've got a function inside of inverse tangent, so I'm going to chain rule. And before I really work the chain rule, I have to figure out what is the derivative formula for inverse tangent. So do you all remember, what is the derivative formula for inverse tangent? You can write it in chat. So I am getting 1 over 1 plus x squared. But again, where the x goes in the formula, I've got to take the 3x, plug it in, and then multiply by its derivative. And then that problem is done. Leave it unsimplified. Now let's take a look at this. And I don't want that. Okay. You are given the formula you need to use. Lag time will catch up in a moment. Or it won't. Okay. Come on, lag time. You can do it. I believe in you. I'm starting to not believe in you. Maybe I should just start reading and eventually lag time will catch up. Okay, spherical snowball. We've got a volume formula for the spherical snowball. The snowball is decreasing in volume. I don't know what your problem is. I don't know why you're fighting me today. My computer is fighting me today. It really is. In period 1, I had to just get offline and restart my computer. Okay. Decreasing volume, 8 cubic meters per hour. So I have dV/dt is negative 8 cubic centimeters per hour. At what rate is the radius of the snowball decreasing? Now, it says at what rate is it decreasing? So that means it's going to be negative, and your answer is going to be what I circled, not the negative part. So they were at least kind enough to only give positive answers. Thank you for acknowledging that's who I wanted to get. Okay. Now, look at any rates of change given. Look at the rate of change you're being asked for. Make sure you have a formula that brings them together and doesn't bring in any extra variables changing, and then you're ready. I'm going to take the derivative of that volume formula. So dV/dt equals constant multiple 4/3 pi times, and then blah cubed 3 blah squared times the derivative of blah. Double check. Do you have both derivatives for v and r? Then you're ready to start plugging in the given information and the when information. So when the radius is 10 centimeters, and we're given that dV/dt is negative 8. So at that point, it's just a matter of arithmetizing. And getting dr/dt isolated. And I believe that ended up giving you, was that the one that gave you 1 over 50 pi? Wait. Yeah. All right, then let's see, we have 5 minutes, 6 minutes left. Do you want to see anything in particular? Yep, 5 minutes left. Anything in particular? 5 on practice test. Ah, yes, that is definitely a good one. You know, I think it's you, Microsoft Whiteboard. You're just lagging. Let me make that a little bit bigger. You will be implicitly differentiating. So I am taking the derivative of both sides with respect to x so that I can get the over dx. So x squared derivative is 2x alone with respect to x. Y cubed is blah cubed, 3 blah squared times the derivative of blah. Then realize you have secant of baby. So derivative of secant blah is secant blah, tangent blah. You must write that x times y in both of those spots. Times, and then take the derivative of x times y. Now, the AP test loves to throw at you x times y or x to a power times y to a power in some way, because people will accidentally not use the product rule. You have to product rule the x times y. So we've got keep x multiplied by the derivative of y plus derivative of x times keep the y. And then on the other side of the equation, derivative of constant, 0. Then, very, very important, when you wind up having to go through a product or a quotient rule while you're in the middle of a chain rule like we are here, you have to make sure that you distribute the multiplication over the addition. Come on, my little lag time friend. And I don't, there we go. So you have to make sure you distribute that before you can isolate the dy. I just realized I'm mixing dy dt in. Make sure you get a good amount of sleep and you come in focused and be talking to yourself about who are you differentiating with respect to constantly. So at this point, we're going to distribute, so the x times dy dx times the secant xy tangent xy, but then also y times, oh, I forgot my, yeah, I did, never mind. And I can either have the parentheses or not. It means the same thing either way. And then from there, it's a matter of the terms that have dy dx. I'm missing the other ones. The terms that have dy dx are going to come together, and the terms that do not have dy dx are going to come together. And we're almost out of time. Is that enough that you can then finish the algebra on that? Study your derivative formulas. Study your derivative formulas. The most valuable thing you can do, though, is get a good amount of sleep and eat healthy and exercise. Is it okay if we, yes, it's absolutely okay. You can use y prime. Okay, it is time. It's 10.